Greetings friends, in this video I'm recording a video tutorial to give a solution to this question. This is question number 2 of May June M1 paper. So this question is from application of vectors in mechanics. Now at first this question provides you with some instruction to look at. So you need just to take care, you need to read and understand what it means. And then we have two particles A and B, each moving on a smooth horizontal surface. Each particle is moving with a constant velocity, so that's the crucial information. At time t seconds, the position vector of A is given by r meters, such that when time is 2 seconds we are having r as -5i plus 16j, and when t is 5 we are having r as 10i plus 4j. So we need to get in terms of I and j the velocity of A. This is a very simple question. So part A, we know that velocity is given as displacement divided by time. So our velocity, we are going to have displacement, which is the change in the two position, that is tan 4. I mean, like when you write 10i plus 4j, you can write it as tan 4, then minus the initial position was at 2t, at actually when t is 2 seconds. So this is a -5 plus 16, then divide by the difference in time, that is a 5 minus 2. And this is going to give us 15 comma 4 minus 16, that is -12, divided by 3, which is going to give us so I mean this one you are going to divide everything by 3, which is going to give us 5 comma -4. So this means that the velocity of this body, the constant velocity, is actually 5i. So you can say 5i minus 4j. So we are done with that part of the question, so we can go to part B. Now in part B, we are supposed to find an expression for r at time t seconds, giving your answer in form of pi plus qj, where p and q are functions of t. So in part B, what you're supposed to do is that to know that r is given by r naught plus vt. R naught is the initial position, and vt, that is the displacement. How far has it gone from the initial position or the origin? So we can use either of these two equations that we have here to be able to get the r naught. So I'm choosing the second equation. You can choose the first equation if you want. So I'm choosing the one for t equals to 5. R is, that is 10i plus 4j. So this is what I'll say. R, which is 10.4, should be equal to r naught plus v, which is a constant velocity, and our constant velocity is it has already been given as 5 -4, and then multiply by 5. Why am I multiplying by 5? Is because that displacement 10.4 is when time is 5 seconds. Now rearranging everything gives us r naught as, we are going to have 10 minus 25, which is minus 15 I, then plus 4 minus 20 minus 20, because -4 times 5 is minus 20. If you bring it to the other side, you're going to have 24 j. So to mean that our r is given as our r naught is given by our r naught -15 comma 24 plus v, that is our constant velocity, which is 5 -4, multiplied by t. So we can separate this one in terms of the I components and j components. So this is giving us -15 plus 5t I, then plus, that is 24 minus 40 j. Like when I'm I'm just organizing this one in X and Y. Just know that this is the I component, this is the J component, to make it a bit easier when I'm handling them. Now in part C, we are supposed to get the bearing. So they've given us the information over there. At time t seconds, the position vector of B is given by that. So find to the nearest degree the bearing of B from A. Now let's see, at time equals to 5 seconds, where was A? The position vector of A at that time was already given in the question. That is 10, 4. So that was the position vector of A at 5 seconds. That is 10, 4. Okay, let me just give it as a vector form. That is 10, 4. Yes, that is okay. And then OB will be given by the equation that has just been provided there for S. This is the displacement function or displacement equation for S. That's what we are going to use. So if you substitute 5 there in place of t, we are going to have -5, 7 plus we have t into 2, -3. So that's if we write it in columnar form, and then let's substitute t as 5. Becomes so if you put 5 over there, becomes -5 plus 5 times 2. Then we have 7 plus 5 times -3. Yes, and this is going to give us +5. Then 5 minus 7 minus 15. This is going to give us, okay, let's just confirm that everything is okay. This is minus 15, 7 minus 15, that is -8. Yes, that is good, that's correct. Now let's get to see what really happens at time 5 seconds. Now at time 5 seconds, the position of A was 10. This is 10, 4. So this is where A was, and then B is supposed to be at 5, -8. So we have 5 in the middle, then -8. So this is the position for B. So this is actually what is connecting the 2 points together. And the question wants us to get the bearing of B from A. So we'll be standing at A to get the bearing of B. So remember, we read in a clockwise direction from the north line. So this is the bearing that we are looking at. So let's do this one as an imaginary triangle so that you can apply SOHCAHTOA. This is from 5 to 10, since it's 5, and this is from 4. This one is from, yes, I think it should be from 4 to -8. So -8, we are having 12. So let's get the angle here. So you can see tan theta equals to 5 over 12, to mean that we can get the value of as inverse tan of 5 over 12, which is going to give you some value there. So let's get the, so I'll get the calculator here. So calculator, fine. Then inverse tan of 5 over 12, and then press the equal sign. We are getting 22.6 degree. 22.6 degree. So this is going to give us 22.6 degree. Now this bearing, we already have 180 over there, then plus the angle inside is 22.6 degrees. So the bearing of B from A is 180 plus 22.6, which is something like 2 or 3 degrees to the nearest degree if you work it out. That's how it's supposed to be done. Thank you for watching. I'm going to cover 3 more videos in this series to ensure that you can practice sufficiently. You can always be pausing to cope up with my speed, and you can also be asking questions where necessary in the comment box. Otherwise, thank you and see you.